So today we're doing percentiles and z-scores. We'll start with a percentile. It's just the percent of the values in some sort of data set, like a distribution, that's less than an individual's data value. Like on our activity today, we had two scores, one of 60 for Marty. He scored better than 0% of the people. He's in the 0th percentile. And that was Biff, excuse me. Marty scored in a 90. He scored better than 80% of the people. He was in the 80th percentile. And then this z-score we'll deal with later, but we'll just kind of rock what it's all about. It was those weird questions on our activity today. It tells us how many like standard deviations you are away from the mean. It tells us how many standard deviations you are away from the mean. And then here's a formula. I'll blow it up a little bit larger so we can see it. This is what we'll do our calculations with today. We'll need a calculator to calculate the z-score. Like I said, we'll understand more of it here later. But it is some sort of value, take away your mean, divided by the standard deviation. Again, once we dive into the questions, this formula will make so much more sense, but it's just like, I always like to put the vocab at the top of the page so when you're looking through your notes, you can kind of just see it all after we've discussed it kind of stuff. So there's a formula to find the z-score. That's sort of the weird thing. I'll bet the percentile you'll find pretty basic today. So let's dive into a couple questions. It says, the following dot plot displays another different class's test scores with Jenny's score marked. Sorry about that. Jenny's score right here is marked in red. Can you kind of see? It's tough on the black and white copy, but this is Jenny's score on the test. And I hope they tell us how many kids are in this class. It says the distribution is roughly symmetric. Are you kind of cool with that? Like if we was to make a little curve, it's basically symmetric, you know, not perfect. It says Jenny's score is probably above the mean because when you are symmetric, like the mean is kind of like right there on the peak of that guy right there. So she did better than the average kid on that situation. And it says we can see that she did better than most. They say find the percentile for Jenny's score. Well, here's what you have to do for that. If they don't tell you how many dots there are, you got to sit there and count up all the dots. I'm going to be nice and tell you there are 25 dots on that screen right there. So on homework, you might have to sit and count them all up, but there's 25 dots. We just got to go count how many scored worse than Jenny. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. How do you feel that I counted 21 dots to the left of that? So to show a little bit of work so you can look for your notes, we take the 21 and divide it by the 25. This, you might even put a little note for yourself, is the total. Right? There was 25 total dots. This is really just for your note purposes for when you take your quiz. You can look back to see how we did that. Go ahead and punch that in, 21 divided by 25. And this is what's called the percentile. Thank you. Made a typo. 21 divided by 25 would be better. Did you guys get 0.84 on that guy right there? So really cool thing is we'll change it. We'll move the decimal 2 places to the right. So she would be in what's called the 84th percentile on that guy right there, the 84th. The 84th percentile. It's just that decimal moved 2 places to the right. It means that she did better than 84% of the kids in the class. All right, so then it says find the percentile for Norman, who scored a 72. So that kind of sucks on this data set. We got to go find Norman at a 72, and he is like, I believe this guy. Let me double check if that's 72. Nope, that's not 72. That's 71. So 72. Norman, yep, it was this guy right here. He was just 1 dot less than that dude right there. Do you see there is 1 dot lower than the 72? So this is Norman right here. And how many dots were lower? 1 out of the 25. So if we divide that, 1 divided by 25, do you see how I got that 0.04 back on that? What would that be if we moved it 2 decimal places to the right? 4 or 40? 4. So he's in the 4th percentile. And the basic idea on this is the lower you are on the dot plot, the lower your percentile is going to be, right? It's like there's not that many dots lower than you. This person right here did the best in the class. Are you with me on that? This is the best, but they would not be in the 100th percentile because there is like 24 dots below them, right? They count as a person, so it would be like 24 out of 25. It is impossible to be in the 100th percentile. That person was in the 96th percentile kind of thing. So real cool stuff there. The other thing is we'll always use like whole numbers. So like earlier when I made my small little typo, do you see like I would have had to round this guy to like probably like 87.5. You can't have 87.5 percentile. You would call it the 88th percentile. You just round to like a whole percentile. So pretty basic on percentiles. If I could stop hitting the wrong button, that'd be awesome. What do you think where the median would roughly be in any data set? You know, median means what in your words? Median means middle. So percent-wise, what's right in the middle of 100%? 50. So how do you feel that the median is roughly at the 50th percentile? It's not going to be perfect every time. You know, sometimes it could be like the 48th percentile or the 52nd percentile. But basically, if you're close to the middle, you will be like better than 50% of the kids in the class at a certain scale or something like that. So what do you think about Q1? Where would Q1 roughly be at what percentile? Not the 50th, but the 25th percentile, is it? Remember quartiles, guys, like where we split it up into quarters? So see if you can figure out where Q3 would roughly be at. I got the 75th percentile. Does that sound okie dokie? And then over here, percentile should be recorded as whole numbers. Whole numbers. We're never going to be in the 4.2 percentile or the 8.9th percentile, either in the 4th percentile, the 5th percentile, the 9th percentile. So just round to the nearest whole number. Some math textbooks have you always round down. On our homework, when I went through it, they'll make you round normal math ways. So if it's bigger than 0.5, you round up. Otherwise, we round down. So cool. Let's see what we got right here. The dot plot shows the heights of 25 students in this lady's class. So sweet, they told us 25. Find the percentile for Lynette, who is 65 inches tall. Go find that 65 dot on your paper and see how many dots are below her. So we don't count this dot. We count how many below. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Does that sound cool that there was 9 dots below? 9 out of the total of 25. So 9 out of 25. And I'll bet that is 0.36. Is that right? So what percentile would that be? 36th percentile. 36th percentile. Yeah, buddy? What do you think about percentile so far? Not bad, right? The main thing is don't count the actual dot that you're talking about. You count the ones below it, right? Below it. So on this dude right here, it says from the table that we have to the right, I know mine's below, but yours is to the right, give the percentile of the value of 56. Sweet. Help. How many total data points are in this spreadsheety type chart right here? How many total? 6. So I have a total of 6, right? And I want to know where 56 is. I have to go find how many of them are lower than 56. They're not in numerical order, so you just got to like count them up, like how many of them are lower than 56. So I feel that this guy is, that's it, right? Isn't there just 2 of them, right? So 2 were lower because you don't count 56, right? You got to be lower than it out of 6. So if we punch that in, that's going to be a nasty little decimal right here. Would you want to, we got to round to the nearest whole number. So moving 2 places to the right, would you keep it 33 percentile or the 34th percentile? Yep, 33rd percentile. 33rd percentile. Cool. It's pretty basic today. Give it a weekend and a couple of days. You'll kind of be like, oh yeah, do we count the one or do we not count it? Like you don't count it, you go underneath of it. All the ones underneath of it. So let's see if we can turn it into like an English sentence that we just fill in the blank. According to the Chicago Tribune, which is a newspaper in the city of Chicago, speed limits on the Illinois highways are set at the 87th percentile of vehicle speeds on those stretches of road. What does that mean? So like they have like the cops out there with the radar guns and they're checking people's speed, right? And would you believe like if you're doing good, you're going what, under or above the speed limit? under, or even equal to, right? You know, so like you're good if you're under the speed limit, you're bad if you're that. So the 87th percentile says it means that the speed limit is set at values that will have blank percent of the vehicles that are less than the speed limit. So that means less than is like a good thing for the speed limit, so it's just going to be 87%. Right? That's what an 87th percentile is 87% of the drivers are doing what they're supposed to do, right? They're going less than the speed limit. But when they reverse it around, what if you're doing the bad thing and going worse than the speed limit? If 87% are doing the good thing, shouldn't everybody else be doing the bad thing? And there's only 100% total, so 100 take away 87 would be how much percent left on that one? So that means 13% of the drivers are being little speeders in that case. So it's all about adding up to 100 for a percentile. When you're under, you're good, and when you're over, that was like bad in that situation. Thumbs up with that. That is percentiles. Now let's get into this z-score thing. So first, again, a z-score is like how many standard deviations away from the average you are, right? On average, how many standard deviations are you? So to find the z-score, we use this formula. Before we do that, let's fill in these boxes. If you have a value that is above the mean, you'll have a positive z-score. And if you have a value below the mean, you'll have a negative z-score. That was what our activity was all about with like Marty and Biff's scores, was like the average in that test was an 80, right? And didn't Biff score like a 60? He was 2 standard deviations below the mean. So like what do you think Biff would have had on his score of 60? A positive z-score or a negative z-score since he was below the mean? Negative. And then Marty had the 90. He was 1 standard deviation above. So let's kind of check it out and just dive in. Mine is a little rearranged compared to yours. Sorry that I blew yours up bigger so you can see these numbers better on your paper. But I'm starting with this question right here. It's actually number 8 on your worksheet. This is an old slideshow, so it's number 7 on mine. But it's the one about Jenny again, right? So it's on your left-hand side. So it says, here's that data from the stats test before. It says, where does Jenny's 86 fall within the distribution? That's fancy schmancy talk when they say, where does it fall? To find a z-score. Right? When they ask, where do you fall? We're going to find a z-score. So here's what we need to do. We're going to write our work like this. We're going to start with z. I'm a math dude, so I always cross my z's so they don't end up looking like 2s. So that's why I make my z's like that. But I'm going to put this little fraction right here, and we're just going to sub in these 3 things real quick. So I need to know some sort of value. That's fancy talk for what did the person actually get. We are talking about Jenny. Do you see how they said she got an 86 on her test, right? So that is the value of the person or thing we're trying to do. So the value, 86. Cool. Then it says take away the mean. We will go to the summary statistics and figure that out right here. Do you see the mean is 80, right? So we are going to just put the number 80 right there. It's her value. Jenny scored an 86, and she got, like, the mean is 80. But then we have to divide by the standard deviation. Do you see it says 6.07 right there for standard deviation? Help me out. Figure this out first, either in your calculator or in your head. Do the numerator first. What's 86? Take away 80. You're always welcome to use the calculator on that, but what would that be? It is 6. So also, just to kind of point this in the right direction, didn't Jenny do better than the mean? So that is a positive 6, right? She was 6 above the average, right? And if we divide that by 6.07, why by 6.07? Because that's just part of the formula. The standard deviation was 6.07. But you see how I just figured out the numerator first? I said, all right, here we go. And we just punch that in. He's going to be nasty, right? He's going to be nasty. Sorry, I keep hitting the wrong button. Divided by 6.07. And did you get this nasty dude right here? Homework will probably have us round that to 2 decimal places as well. Right? So we won't change it to a percent, though. That's the weird thing. It's like we're not finding a percentile anymore. We're finding a z-score. So we're going to do 2 decimal places. So we're going to look right here to the third guy. He is 5 or larger, so how do you feel about rounding that up to 0.99? 0.99. And I made it come out nasty for a reason, right? So her z-score is about 0.99 because they usually come out nasty, but let's talk. Is 0.99 like basically the number 1? Are you with me? How do you feel that Jenny is damn near 1 standard deviation away? Isn't it like 6 and 6.07 almost the same number? Like she was basically 1 standard deviation above the mean. It is a positive value because she did better than the average. So Jenny's score is 0.99 standard deviations above the mean is what that means. Jenny's score is 0.99 standard deviations above the mean. And that's pretty weird at first, but we'll get better and better and better and better at understanding it after doing more examples. Little example, but even after only one example, I'll bet you could tell me the answer to this question. We're going to find Lionel's z-score. Lionel got a 67 on his quiz, and the average was an 80, right? So what do you think? Should his z-score be positive or negative if he did worse than the mean? Positive or negative? What do you think? He's going to have a negative z-score. So how do we set it up? We do it just like this. We'll do z equals the value. That's the weirdest part. It's like, what do you mean by value? It's whatever that person got. Didn't Lionel get a 67, right? So that's the value. Then the other numbers never change for this scenario. The average is still 80, so we're going to take away the average and divide it by the 6.07. And man, if you figure out the numerator first, you probably won't make any typos in your calculator because you can't just type 67 minus 80 divided by 6.07 because it's going to do the order of operations. So figure that 67 minus 80 first. And ta-da, it's negative, right? Negative 13. Why did it turn out negative? Because he's lower than average. And if we divide that by the 6.07, we'll get our z-score. Negative 13 divided by 6.07. And he is more than 2 standard deviations under the mean. Negative 2.14 situation. Which is really, really weird to understand when we're new at this. So let's see if I can put it into a nutshell for you. The average in this class was an 80. People averaged an 80 on this quiz. But most students are probably within 6 of the average because that's the standard deviation. I'm just going to use 6 instead of 6.07. Most people scored within 6 of that, right? So like here that is. This is the 80, and most people, if I go all the way down to 74, which is like right here, all the way up to 86, would you believe most of the dots are within 1 standard deviation of the average? But Lionel, he was way down there. This is him. He was way down there. Wasn't he more than 2 standard deviations below the mean in that case? That's the z-score. It tells you like how well you're doing compared to the average person. And Lionel was 2 below the average person. So 6 and another 6. He's like 12 points lower than the average, roughly. So let's try one last one and see if it can kind of make some sense because it lets you know how people are doing and compared to other things. Last one of the day, I think, is about Yolanda competing in some sort of event called the downhill. So we're doing some skiing events. And then Rita, she didn't do the downhill, she did Super G, right? Different like snow skiing events like in the Olympics. So here is a chart right here of like the average for the downhill and the average for the Super G and also their standard deviations. Let's just focus one person on at a time. Yolanda competed in her event. She got a 195 in the downhill, right? What is Yolanda's z-score? Let's start. The formula is z equals her value. What is Yolanda's value in the downhill? 195. Then we need to take away the average. We've got to go to the chart for that. The average, which one do you want, the 186 or the 200 for Yolanda's score right here? What event is she in? She's in the downhill, so you better use the 186. Isn't that the average in the downhill? And we have to divide that by the standard deviation. Isn't the standard deviation 3.9? Are we cool with that? So punch that numerator in first. We will punch that numerator in first. 195. Take away 186.1. Hit equals, and then divide that by 3.9, because that's the standard deviation. So 8.9 divided by 3.9. I got this nasty dude, round that to 2 decimal places. Did you guys get the same number I did? 2.28-ish? Yeah. Cool. I'll let you guys find Rita's z-score, right? Rita is in a different event. She's in the Super G, and her score was a 208, right? So can you find that z-score? Just pause the video, give that a shot, see what you think. So I got 1.03. So they ask who performed better in their event relative to their field competitions. You know, the weird thing is this is a race, right? So when you're doing a race, like a faster time is better. Like, what would you rather do? Win a race in 10 seconds or win a race in 11 seconds? Like, isn't the lower number going to be the better score? So when we look at these z-scores right here, the one that's lower is actually going to be better, right? So that would be, sorry, not Yolanda, but Rita. I have a mistake right here. Rita has a lower z-score, meaning she raced faster. But when it came to like test scores, you know, like I think a score of 90 is better than a score of 80, so 90 is a higher number. You'd want the higher z-score. It's about the context of the question. It's like, okay, if it was a race, I would rather have a lower time. If it was a test score, I would rather have a higher time. So if it's supposed to be higher, you want a bigger z-score. If it's supposed to be lower, you want a lower z-score. So let us know if you have any questions. Have a good one.